Hi, I'm Kuba, and welcome to the first episode of Bielik Anatomy series. So I've been exploring Triton lately and thought, why not implement a language model from scratch to really understand how it works? And I want to take you on this journey with me. We'll build Bielik, which is a Polish language model, using GPU kernels written in Triton. I will be honest, I'm learning this as we go. I might make mistakes, so we might need to go back and fix things, but that's a part of the process. Anyway, I think we'll learn a lot, and this will be a great journey. Today let me show you what Bielik is, why I picked Triton for this project, and what we are going to build together. Bielik is an open Polish language model created by the SwiGLU community, which I actively contribute to. The version I'm working with is Bielik version 3, which has 1.6 billion parameters and is based on Qwen-like architecture. What caught my attention? It uses some really interesting architectural improvements like grouped query attention, SwiGLU activation and RMSNorm. And since it's focused on Polish, it's perfect for us to learn with. Let me show you how Bielik is structured at high level. Input tokens go through an embedding layer, transforming them into vectors. Then we have 32 decoder layers, the heart of the model. After those layers, we apply RMSNorm for final normalization. And finally, the language modeling head projects back to our vocabulary tokens. Now we get to the interesting part. Each decoder layer has two main components, grouped query attention and a SwiGLU feed-forward network. I will focus on GQA as it plays a crucial role in this architecture. In a standard multi-head attention, if you have 12 attention heads, you need to separate key and value projections for all heads. That's a lot of memory, especially when you are working with longer sequences. But Bielik uses grouped query attention. We still have 12 query heads, but only 2 key value heads. Each key value head is shared by the 6 query heads. And the savings are significant. We are talking about a 55% reduction in dimensions, smaller memory footprint, faster inference, and from what I've read, similar quality to standard attention. Pretty cool, right? Now let me tell you why I choose Triton for this project. CUDA is really difficult. You have to manually manage blocks, threads, shared memory, and synchronization. A simple kernel can easily become 100 lines of boilerplate just for optimization, and the code isn't portable between different GPUs. Then I discovered Triton. It's a Python-like language for writing high-performance GPU kernels with automatic block management and compiler optimization. The syntax is actually readable, the compiler does auto-tuning for you, and it works across different GPU architectures. Here's what really sold me. Implementing RMSNorm in PyTorch launches 3 to 4 separate kernels. In Triton, everything happens in one kernel, one pass through memory, and it's 2 to 3 times faster. That's a kind of performance I want to understand and achieve. So what I'm planning for this series? I want to start with the basic kernels, matrix multiplication, RMSNorm and softmax. Let's get the fundamentals right. Then we'll dive into the attention mechanism, rope, scale.product attention, and I really want to try implementing flash attention. Next, we'll tackle the feed-forward network with SwiGLU activation. And finally, we'll put it all together and try to generate some text. Maybe it will work perfectly, maybe we'll hit some bugs, we'll see. Sounds good? I think together we'll learn a lot. Thanks for watching. See you in the next episode where we'll write our first GPU kernel. Don't forget to subscribe and drop your questions or ideas in the comments. I would love to hear what you are thinking. Bye!